Hey guys, I just wanted to do a little bit of review before you have your quiz. Just because some people are still struggling a little bit with the Punnett squares, so this will just be like a little Punnett square review. So we'll start with the small Punnett square. So one like that. And we'll say the problem says to cross a heterozygous tall plant with a short plant. So just in figuring out what the parents are, heterozygous tall tells you that tall is the dominant allele, which tells you that, and we'll just put this one up here. So heterozygous tall means that it's going to be big T, little t. So you take this T and you put it here, and then you take this T here and you put it here. So that's just, these are all the possible alleles that this parent could pass down. It can pass down a big T or a little t, so that's what we're putting here. For the short plant, okay, in order to be short, because tall is dominant, in order to be short, you have to be little t, little t. So we'll put this one here. So that's that little t. We'll put this one there. So that's what this parent can pass down. So then just fill this in. So big T, little t, little t, little t, big T, little t, and then little t, little t. You may be wondering why I make the little t's like that. Honestly, I don't make my little t's like that in anything other than genetics problems. It's just so you can really tell the difference between the capital T's and the lowercase t's. A lot of times using a slightly different version of a letter is good. Like we'll say you could use like capital L and like a cursive L or something like that. So that's why I do it. Now, to get the genotypic ratio for this problem, the genotypes are the combination of alleles. So we have 2 big T, little t, to 2 little t, little t. Oh, I should put 2 in there. So that's that. So that's the genotypic ratio. The phenotypic ratio is just what do they look like. So these big T, little t's would be tall. So you have 2 tall, 2, and these would be short. Okay, so that's what that looks like. So that's one of the simpler ones. That's one of the monohybrid cross. Let's look at a dihybrid cross. Okay, so dihybrid cross, oops, screwed that up, is going to be one where you have 16 boxes. And we'll say you're going to cross a heterozygous tall plant with homozygous white flowers with a, let's say, homozygous tall plant with heterozygous purple flowers. Okay, so first thing we need to do, figure out what the parents are. So heterozygous tall plant, okay, so that's going to be big T, little t, with homozygous white flowers. Now, we don't know if that's dominant or recessive, so we need to come, so this homozygous white flowers, we need to look and say, okay, heterozygous purple flowers. What this means is that heterozygous purple tells us that purple is the dominant allele. So this would be lowercase p, because we'll use the p because purple is dominant, and because this is homozygous white, that means lowercase p. Now over here, with a homozygous tall plant, so big T, with heterozygous purple flowers, big P, little p. Now let's look at our combination of alleles. What are the possible combinations? So we have, and we do FOIL, right? First, outer, inner, last. So the first here would give us capital T, lowercase p. Outer would also give us capital T, lowercase p. Inner would give us little t, little p. And last would give us little t, little p. Okay? So that's that. Over here, you have first would be capital T, capital P. Outer would give you capital T, lowercase p. Then inner, capital T, capital P. Last would be capital T, lowercase p. Now, you may notice a couple things here. One, these are just all the possible combinations that you can have here, right? So that's what that is. Every possible combination that you can have. Okay, but a couple of these are the exact same. Like these two columns are the same. So what does that mean? We can cross one of them off. These two columns are also the same. So we can cross one of them off. And you have two of these and two of these, so you can actually cross these off. Okay, this makes this a little bit more manageable. So we have capital T, capital P, lowercase p, capital T, lowercase t, capital P, lowercase p, capital T, lowercase p, and capital T, lowercase p, lowercase p. All right, I'm just going to move this up here. And let's do our ratio. Our ratio would give us how many of these? We have this one, and that's it. So we have one of those. Two. Then the next one is capital T, lowercase p. We only have one of those as well. So that's that. Then over here, we have one that's heterozygous for both, and that's that one. And then capital T, lowercase t, there. So that is our so this is our genotypic ratio. Our phenotypic ratio, now we don't even need the Punnett square anymore because we have the genotypic ratio to go from. So this one right here is going to be tall and purple. Do we have any others that are tall and purple? Well, yeah, we have both this and this are going to be tall and purple. So we have two tall and purple. And then this guy is going to be tall and white. So that's this, and then what's this? This is also tall and white, so that would be two tall and white. So this is our phenotypic ratio. So hopefully that helps you. I'll post this, watch it, and hopefully it helps you kind of going forward.